Apple Adam, you don't have to be mean like that. Any 116 student who's still here and wants to hang out, by all means. A lot of 442, it's language independent. It's very general, broad information. Even if you're in 116, you might be able to get something out of the lectures here. Is there lecture activity today? Thank you for typing it like that, because now I know you're joking. Or if you put a kappa next to it, I know you're joking. And yeah, XX, I remember your name. You were the one who did it last time. It's it's not that big of a deal. I just want to make sure they know that they are welcome here. 116 topics got to go, though. We're not talking 116 topics anymore. All right. So Matt sent me this message, and I was wondering why he was sending this. Holy crap, Sprint 1 is due next week already. This class moves fast. This semester is moving really fast. Can you believe we're done with week 4 after this lecture? Week 4? Oh my goodness. So anyway, Matt sent these reminders. I just cut and pasted his message, took a screenshot of his message directly, and to show it to you, to make sure that I don't miss any words in this, and I'm going to try to read it verbatim, just to make sure that I convey to all of you that what's expected of you coming up. So there are a few things that are a little different for a grading week that we want to make sure everything's said and out there. Your PMs probably told you that some of this week, but if some of the PMs didn't, I assume that's why Matt's making sure I remind everybody. So anything that's done, you don't have to wait for your PM to close out your tasks this time, because it's a grading week. So make sure any completed tasks and stories, close them out before your grading meeting. Your PM will not be closing those out for you this week, only during grading weeks. And make sure you don't merge anything that's broken or incomplete. If you didn't complete a task for this by the end of this sprint, don't merge it into develop. Please don't merge it into develop. Your team has to demo something. If you're that teammate who's pushing broken code, merging broken code into develop right before a demo, your team will hate you. I promise. I guarantee you that. Don't be that person. I've seen it happen. It happens all the time. Not just in this class, but everywhere. You got a big demo coming up and somebody's like, oh, I'm working on this feature. I really want this feature showed off in the demo. And they merge it and there's merge conflicts and everything's broken. Don't do it. Don't do it in this class, especially because, it's the rule of law for this class. So anything that's not complete, don't merge it. Don't close it. Make sure it's still on your Scrum board as in progress. It's okay that you didn't complete the task, in some cases anyway. It's okay that you didn't complete the task during the sprint. Maybe it was a large task or something. If you only had one small task and you didn't complete it, that'll reflect in your grade. But don't merge that broken code in there thinking that, well, I'll just pretend I finished it by merging it in. So hopefully that's clear. Don't merge or close anything that's not broken. You're going to pick up on that with that on Sprint 2. And then other times your PMs will close during non-grading weeks, which I'm sure you're aware of. So, and meetings next week, you're not graded by your PM. You'll be graded by a PM from another team, from somebody else in 404. They'll do the assessment. They'll give that assessment to me, and then I get to figure out all the final grades at the end of the semester. I get to combine all that. I'll also have peer evals opened up. I'll send you the information for that on how to do your peer and self-evaluations. I'm sure you've seen the rubric, but I'll send out the logistics of how to handle that. So you can do all that good stuff. So is everything clear for what you need for Demo 1? Because this is next week. I hope you're all more aware of that than I was, to be honest. I can't believe that deadline came up so quick. You got 3 weeks of coding in already. The horrors of 116. 116's all right. You're still saying that? The horrors of 116 after you've gone through 220 and 250? Actually, you might not have given... If you're a senior now, you might not have gone through 220, but at least 250. Have you had 331 yet? 116 still giving you nightmares? Ooh, boy. We only graded on which push to GitHub. I think that's on this. Oh no, it's on my very last slide of the slide deck. But no, you're graded on. I mean, we can check what's on GitHub. If you don't have anything pushed to GitHub, you're not getting graded for it. But the demo is your primary means of being graded. You're going to demo to the demo PM, and they're going to grade you based on what you show off there. So if there's something that's not shown off in that demo, even if it's in your GitHub, it's as if you didn't even do it. So make sure everything's demoed in that demo, and you should be demoing off of your off of your master branch. Actually, now, this is a release, so you should merge into master for the demo. And whatever's on your master branch at the time of that demo, we might refer back to that to check the state of the code. But if it's not merged in your master branch, you shouldn't be demoing it. And talk to your specific PMs whether they want you merging into master or not. This is usually where a merge to master would happen, but I'm just not sure how that's been communicated throughout 404. Yeah, 250 is worse. 250 is more technical content than 116. It's just generally harder. That's why I said that. Yeah, 250 should be scarier. No matter who's teaching it, regardless of instructor. Who said I took any of those classes? Yeah, if 116 is the only class you took, yeah, I guess that would be the one giving you nightmares. Yes, exactly. I can't convey this to my 116 students enough. They complain about how hard 116 is. I'm like, I have to prepare you for the twin bosses of 220 and 250. If I don't push you hard in 116, you are going to fail next semester. And I can't get that through their heads until they get through 116 and then they see what next semester is all about. And then they're like, holy crap, you were right. I try to warn them, but they think I'm the bad guy. They don't know what bad is yet. They don't know what hard and difficult and time consuming is yet. They'll find out. And then in 220, 250, it just gets harder after that too. Anyway, let's get through some slides. No questions about Sprint 1. Everybody's aware that you have a Sprint 1 demo next week. No questions about this. I'm going to plow into lecture. Whoop whoop, cohesion. Should we build our project for Sprint 1? That one has to be a troll, right? Whatever your PM assigned to you, you should be completing those tasks by Sprint 1. Whatever tasks are assigned to you. So our demo is during our PM meeting. I believe it should be at the same, it'll be in the same time frame. It'll be during your recitation time, but it'll be with a different PM, and they're going to send you contact information over the weekend. Because different TMs might have different ways of doing things. They're allowed to use things other than Zoom, so they might have some other type of meeting for that. And at the very least, you're going to need the Zoom meeting link for that specific PM that's doing your demo. I don't have a group yet. That's definitely a troll. 116 light, 250 easy, but 331, that scares me. Yeah, you're definitely ahead of the curve. Usually it's 116's hard, 250 scares me, and 331 is haunting me for the rest of my life. So you're doing pretty good, random username. Okay, let's get into some stuff. So what have we done so far in this class? What have we done so far in this class? Just a quick recap of kind of what we've done in Sprint 1, now that Sprint 1's coming to a close. We wrote user stories. We wrote acceptance tests, ideally with your client, but with your PM and with your teammates. You're kind of your own clients in this course. We chose what user stories to work on for Sprint 1, broke those user stories into tasks. Each teammate gets some tasks assigned to them, and then worked on those tasks while updating a Scrum board and working on the project. What we haven't really talked about yet is how to write code. It's going to sound silly at first. You know how to write code, but how do we write code that's structured well, that makes it easy to test, easy to expand, and easy to reuse. This is what we really want. This is our goal, and this will be the goal for these next 3 lectures. We're going to talk about cohesion, and then I forgot core. That's embarrassing. The next lecture's topic, and then testing, writing code to be tested. Cohesion. Oh, coupling. Cohesion and coupling. These are. That's embarrassing. These are 2 topics that go hand in hand. That's what the next 2 lectures are going to be. So what have we done? Set up our project management, and it's going to be time to write code. Hopefully you've written a good amount of code so far. A lot of you might have been doing research tasks for a couple of weeks here and other activities. But it's definitely time to be thinking about writing our code and designing what our programs are going to look like and what our modules are going to look like. And a quick recap of software development life cycles. What we'll mostly use, what you'll probably end up using in this class, no matter what you call it, Wagile is one way of saying it, is a combination between Waterfall and Agile. So we use Agile for a lot of things. One of those things where we're being agile by breaking the work into sprints and getting bite-sized chunks for each one of those sprints to work on. And then for each one of those bite-sized chunks, for each task that you work on, you might be using more of a waterfall method. You look at it, okay, what are the requirements of this task? Not at the project level like waterfall, but for this task, what are the requirements? What do I need to build? Okay, let's talk about what that means. What does this need to do? What does that mean for me? What am I going to build? How do I actually build that? And then finally actually writing the code. So if you're not here, we're going to pretend, but your project might be right about here at this point. You've gotten the requirements, you know what needs to be done, you kind of know how that's going to get done, and it's time to design at the code level. Analysis is kind of designing more at the business level and the user level. Now we want to start designing at the code level. How are we going to design and structure our programs and our projects to be able to have good usability, good expandability, and good testability are big things that we want. So let's talk about it. Just a reminder, communication is always important. This will be probably in every lecture. We'll talk about communication a bit. Is making sure that your definitions for everything are consistent across all of the different planes and different stakeholders. So at this point, we're down to the task level. We broke a story down into tasks, and it's time for a developer to start really turning that into software. And there can be at times where the requirements are different across these domains. Maybe your specific task that you're working on, the requirements don't exactly fit the user story in the acceptance tests or even the client's underlying needs at some point. So if you're working on a task like that, you don't want to go into designing the code and analyzing what you need and actually writing code. You need to fix that miscommunication first. So this is one very important step before you actually get on the front lines and start writing code and working on things. Make sure, double check all your documentation to make sure that task you're working on actually makes sense in the context of the project. If there are any differences, if there are any inconsistencies, you got to come up with some way of figuring it out. I don't recommend this first one. Completely rely on one as if it controls all the others, especially if you're choosing your task as being that one. This is the equivalent of forcing a push in GitHub, in Git, just forcing and overwriting your teammates' changes. Really what we should do is look at the conflict and treat it as a merge conflict and merge the requirements together in a way that makes sense all around. Usually if there's an inconsistency here, it's some fundamental misunderstanding on someone's part. And you got to work through that misunderstanding, make sure everybody's on the same page. So work through all the documents, look back at your notes, whatever you need to do. Either you can merge it or you do, to go with the Git analogy, wipe the whole repo and start from scratch again. Whatever you have to do to make sure that there's no miscommunications and discrepancies between the requirements before you start working on a task. Don't work on a task and just plow through it like, I'm sure this is fine. Or even worse, your interpretation of what that task means. Don't go off of that and build something that is useless to the team. That's a waste of your time. So make sure everybody's on the same page, and make sure all the tasks, especially when you're working in parallel, you split up the tasks and work in parallel like you're doing. Make sure that all of your code is going to interact with each other well, and avoid those integration errors. Once you all merge to develop, all your code is tested and works great on your laptop and on your branch. You all merge to develop and everything just blows up. Avoid those things, and the way to avoid that is communication and making sure you're building your code and completing your tasks in ways that are going to work with everybody else's tasks. And a reminder of the need for changeability and adaptability. This wonderful quote: "We're always trying to build more and more idiot-proof programs. User interfaces have come a long way." I think this is a great thing overall. We're building better interfaces, better usability, and this applies to our code as well. The code, if we're writing an API that our teammates are going to use, we want to do the same thing. We want to make that code very easy to use. This is a fantastic thing. Fortunately, the universe has to fight against us, and arguably the universe is winning. The easier software is to use, the easier people expect software to be to use. I remember the first computers. I'll give you a back in my day. Computers used to be really difficult to use. You had to know command line stuff. Back in the old Commodore 64 days, you had to put it in a disk. It was just a command line, and you had to figure out how to boot from that disk to be able to run your game. And then often things would crash. You'd have to go into debug mode. And these were just users. As a user of a computer, you had to be able to have a pretty good understanding of how the computer worked. These days, you hit a button, it's supposed to do everything, and then you complain because you have to hit 2 buttons. And I argue that this is a good thing. We're getting more usability and just kind of going through the evolution of usability for computers. And now we're on this verge of being able to just talk to our machines and have them do what we want them to do. It's come a long ways. And also the user base is expanding. People who are fairly computer illiterate can use a computer now. That's part of the market expanding and everything into getting more people who aren't quite as tech savvy using these things. So those are the kind of users we have in mind. And for today's lecture, we're going to talk about that in the context of other software developers and other software engineers using the code that you've written and having that work well. Same idea applies. You want your code to be easy to use by other developers when they're using your code as a library, as a module that they're going to call from their code, use your methods, use your classes. We want to make sure that's nice and easy for them to use. And usually people get frustrated with software engineering. Matt actually did put words behind these, which I thought was interesting. I'll spoil the long one because I'm interested too. It says something to the effect of, whatever I put here is probably better. I'm curious what you thought was behind this black box. is something to that effect. I'm curious what you think was behind that before I spoil it. What's behind that black box? So to this end, we want to make our code easy to use and easy to expand and easy to test. So when people think our software sucks, we probably want to go in and start changing things. We want to update things. And if we follow good practices of cohesion and coupling, that's going to be a lot easier to push those updates. It's going to be a lot easier to write that patch and fix our code to be able to address these issues that people present to us. Without good coupling and cohesion, it's going to be tougher to be able to make those updates and fix those issues. And we're probably going to create more bugs as we try to fix a bug if we're not following principles like this in general. These are fantastic principles to follow. So let's talk about modules. You've heard of these before. The concept is different in each, applies across all languages, but the actual specifics are different for each language. Some languages just call these straight up modules. Or depending on how you define a module, you can look at it as other things. I say like packages in Java or Scala, I consider those modules. And then even individual classes are modules, so we can have multiple layers and levels. in any programming language, creating a new directory, I would call that a separate module, and then the files in that directory. So you can have multiple levels of granularity for defining what actually is a module. In general, let's call a module some grouping of code that's all kind of grouped together in some way, kind of the very loose definition of what a module can be. And with that, let's define cohesion. Cohesion is the strength of the relationship between the actions. So how strong is that relationship? Or the word I skipped is pretty important. How do we describe that relationship between the actions? So these actions, for these two examples, have lots of functions in them and lots of functionality that are all very cohesive. They're all strongly related to each other because they're right next to each other. They're in the same module in our context. But these have very poor meaningful cohesion, or overall cohesion, as the slide says, where this knife here, we have a few different utilities that are all kind of related. I need to cut something, or possibly I need to screw something. Like there are certain tasks where this is the appropriate tool, and all of the functionality of that tool you might use for that function. So this is really good cohesion because it makes sense for these tools to be together. This has very low or very poor overall cohesion because these tools are not quite related. If I need a pair of scissors, I don't need all of this other stuff. It's unlikely that I'm going to go into a task that needs a pair of scissors and also all of this other crap. This is very poor cohesion. This needs to be broken down into other modules. This stuff doesn't really belong together. This does actually exist. This was a product that existed and was sold just, as a joke. But this was a real thing. This utility knife, or I don't know if it was made by Swiss. Maybe it was Swiss Army knife. Is they're colloquially called. Yeah, the idiot-proof programming. Proof programming? Idiot-proof. Oh, yeah, I read that right the first time. Yeah, making programming idiot-proof would be... I mean, it's getting a lot closer. The tools we have with IDEs and the like, and package management systems, programming is so much easier than it used to be, just so you know. But not quite idiot-proof yet. When it does become idiot-proof, my job will be a lot easier, though, on the plus side. And I think we'll get there. It gets closer all the time. Abstractions on abstractions and abstractions. So we'll talk about cohesion in 7 different levels. So there are 7 different kind of types of cohesion. And we'll go in them roughly in order of worst to best, though there is a lot of discrepancy between what's considered best. It's going to depend on your specific application, your specific tastes and style, the style of your team, and just deciding what's the best approach for a particular problem in general. So there's loosely a worst to best progression here, but it's not necessarily worst to best for specific situations. And cohesion is hard. By the way, this is very hard to do. I might as well spend some time on this. Cohesion is a very tough thing to do, but we do get those 3 things I keep mentioning: usability, expandability, and testability. But it is tough. You're not going to just write good cohesive code on accident. This is something that needs to be thought about. It needs to be thought about at the design level, when you're designing the code, when you're analyzing in that waterfall image, when you're at the analysis level. If you're trying to add cohesion after you've written code, you're looking at a big refactoring job, which sometimes maybe that's the best way to do it because you didn't know where you were going with it at first, and then you write a bunch of crap and then refactor it. I've certainly done that before. But if you have some planning beforehand, it always helps to go to a whiteboard, is the way I like to do it. I'll go to a whiteboard before I start typing any code for a new project, and I'll sketch out what I want the modules to be, what each module should do, how they interact with each other, any APIs between them, is well worth the time invested in doing that, instead of having some really mess of a project that just has a bunch of features that don't really seem to belong together, just all slapped together in a haphazard way. This is not a great way to code. It's probably the way you've all been coding, and there's no reason for it not to be the way you've been coding. But your code, especially any code for assignments that you've written, maybe if you've worked out a side project, you've thought about this a bit more, but any hackathons or programming assignments, this is usually what the code looks like. Horrible cohesion. Maybe it works, maybe it doesn't, but it certainly doesn't have very good properties. The code itself, the individual lines of code you've written might be fantastic, but the overall structure of the project is probably pretty poorly planned, or not planned at all. Or maybe it is. I mean, maybe you are fantastic at that. I don't want to pass judgment. But my guess is, and from code that I see from students, it's just something you haven't thought about yet, which is why we're talking about it. So let's talk about these 7 kind of layers or levels of cohesion. Let's start with the one you're probably most familiar with, coincidental cohesion. This is where there's no thought, no planning gone into it, like I just mentioned. And if there's any decent cohesion in the project, it's strictly a coincidence. So all the methods and code are just all over the place. Maybe you have all your code in one giant main method, or maybe you have, like these developers had, it's a Fortran program, which was effectively just one long method, and they had a manager who read up on cohesion and said, "Hey, this is something that we really want. We want some cohesion and encapsulation and some of these cool things. Can you add that stuff to our code?" So what they did was looked at their code, printed it out on one big sheet of paper, back when paper used to be perforated and you could do that. They took a ruler and they measured 6 inches, and every 6 inches they would split the code into a separate function call, and then they would just call all those functions and have it split, superficially split into separate modules. Kept the manager happy, but it didn't improve the quality of the code at all. It was a completely useless practice. So just having superficial cohesion or coincidental cohesion, obviously not going to really benefit your project. It's not going to help, usability, expandability, and testability. It's not going to help any of those 3 things as you go, and you're going to end up with code like this or comments like this, where half of your comments are just warning other developers to stay out. I've certainly written comments not quite like this, but I've had those comments where it's like, "Trust me, this works. Don't touch it. I know it's the worst code ever, but you know what? It works. Let's move on." I'm never proud of it when I write that. But if you're writing something like this, when you're this into how bad your code is, maybe rethink your design. Very hard to work with that kind of code. So let's go up this progression, talk about the next best thing, logical cohesion. This is where your functionality in your data is kind of grouped somewhat logically. You're thinking about what goes together, and you actually attempted some cohesion, but it doesn't quite make sense. The groupings are not really perfect, not very great. For example, grouping all of anything that takes a mouse click and grouping them all together, or anything that, in this case, anything that's a candy, group it all together. Maybe those bits of functionality in that data are very different and they behave very differently in your program, but there's at least some connection between them. And depending on how you put these all together, if you have some variable that your method is taking, maybe you have one method in your program named math, and it takes the arguments for some mathematical function and a string depicting which function you want called on these inputs. Maybe that's how your idea of cohesion is. It's an example of logical cohesion. it makes sense for everything that's math to be together. But if you're not thinking about how to put them together, like usually the math functions are each separate functions or method calls that you call. If you throw all those in one method, yeah, I guess they're related, but it's a pretty bad way of writing cohesion. In that example, you're going to have if function equals ABS, else if function equals sine, else if function equals cosine, else if function equals square root, in a huge mess of code, which is of course going to be tough to test. You have to make sure all those conditions are hit. You're trying to write one test for 100 different pieces of functionality. Can be very poor if you're organizing like this. And it's very easy to miss things. If you miss one function that a user might want to call, they might try to call it with that function name. You might have misspelled it with that function name. You might have tried to shorten it, like SQRT instead of square root, which is, we're used to that abbreviation. But what if it's a different abbreviation that we're not so comfortable with? It's very it can be very tough to debug. This is an actual chart of when modules grow in complexity, and I believe this is by lines of code, how problematic that is and how likely there is to be a bug in those modules and in that code. Obviously, it goes up. As you get more complex modules, chance of you having a bug in that module is going to go up. Intuitively, that's a thing. You kind of know that's going to be true, but this graph proves it. I don't know. So that this kind of makes sense. At least here, we logically put everything that can fit in a Swiss Army knife on a Swiss Army knife. Sure, there's a logical reason why we group those things together, but it's not a good reason to be able to do that. And if we change anything on here, say we swap one of these tools out for a different tool, we have to test everything in this. We have to test every single tool again to make sure that that still works. This isn't testable. It's not expandable. It's not very usable either. It doesn't hit any of our key points. So it's not really what we want to do. Temporal cohesion, we're starting to get a little better here, but this is still generally referred to as a bad way of grouping things together. This is going to group things together based on the timing of when they often happen in your app. So if actions are usually happening at the same time, we're going to throw those in the same module. This is okay, but it doesn't always make sense. You don't really know why you're grouping them like that. Typically, just because things happen at the same time doesn't really mean they're related to each other. An example of this would be if you have an event where, say, a user is updating their password on your web app, and you write one module that handles all the things that happen because of that. So you're going to want to send some feedback to the user, something saying, congratulations, your password has been reset. You might also want to send them an email. So feedback on the web front, you might also want to send them an email like, hey, just so you know, your password was changed. If this wasn't you, look into that. You're also going to want to go to the database, rehash the new password and store that in a database. So you have some you have some hashing going on, database storage, network communication, and email sent. And maybe you also want to log this event in your server logs. You want to say, hey, somebody just updated their password, and store that in the server log file. So we have a lot of different things happening when somebody updates their password, and they all happen at the same time. User takes this action, update password, and all these things have to happen at that time as a response to that event, but they're not really related to each other. So the hashing a password and storing the hash and salting passwords, that's not really related to the feedback that you're going to send the user. Yeah, they both happen when they update their password, but those shouldn't be in the same module, in most cases at least. Maybe there's a time where this really makes sense, but it really doesn't make sense to have one module that's handling all of that stuff. Imagine one big function that says, okay, log this, update the database, do the hashing, send this to the user, fire off this email. without breaking that into separate methods and then just calling those 5 methods. Having that all in one spot would it's not very good. And especially for reusability and expandability, you want to be able to reuse this code in other modules for other purposes. And if you're hard coding how to log this event, well, there are other things that are going to happen on your server that need to be logged. So it makes more sense to have one logging module that you use and call from all your other code and say, oh, I need something to be logged. Let me defer to this other module and say, hey, can you log this event for me? And then that module takes care of it from there. It doesn't make sense to have that logging code just scattered all throughout your code base. Put all your logging in one spot, put all your database interactions in one spot, and then break those down into different pieces of functionality as well. Can help your reusability of all that code and testability, expandability. So temporal cohesion, it's if you have all those actions happening in the same method, this is like a steamroller. There's no stopping it. It's just going, and that's it. Once that user triggers that event of updating their password, all of that stuff is going to happen, and you can't intervene. Like maybe you want to do a 6th thing when somebody updates their password. Maybe you also want to fire off a notification to IT or something. I don't know. I don't know if they'd want that, but if you want to do something else on that event, it's hard to update that. If you go right into the middle of this big method and try to add some code, well, you better retest everything, because making that change is going to be expensive. You might break something unrelated to that change. The next thing, procedural cohesion. And I'd say this is kind of the line where we're starting to get into cohesion that has some good benefits and some good properties. Procedural cohesion is grouping things together that all happen as part of a single thing that happen differently from that's so terrible way of saying it, but this is different than temporal cohesion. These will all happen in sequence, but not necessarily just everything that happens at the same time. So going to the update password example, maybe this is handling just one part of that process, where the actual updating of the password without all the side stuff jammed in there. So maybe this is grouping together, accepting the request with the new password, 2 versions of the new password, doing the check to make sure those new passwords are valid, they're long enough, they satisfy your criteria, and that they match, and then sending that off to the database, having some other module handle the actual storage in the database, and then having this same module respond to the user saying, hey, cool, I got your password, and everything was updated, great. Or, hey, your passwords didn't match, maybe try this again, because you're not so good at this. And that whole procedure happens all at once. It's still not the best cohesion, because that should probably be split into a few different things. Accepting the user requests, processing the user request, and sending the response should both be 3 separate pieces of functionality, in my opinion at least. But having all 3 of those together, that would be procedural cohesion. You can break that down further. You still have some code that's linked together quite a bit. So what if you want to verify 2 input passwords, verify that they meet all your conditions without necessarily getting it from a user through that web interface, through that specific API call. You can't reuse that code somewhere else. Maybe you want to reuse that code for your, oh, that's a bad example, but, well, I'm going with it anyway. What if you want to reuse that code through your mobile app, and for whatever reason the endpoint is slightly different? You have a different endpoint. You still want to grab that password, those 2 passwords, and send them to the verification module. But if you hard-coded that to be just a web app, getting that web request from that one API endpoint, it's going to be tough to reuse that code in your next one. So it's a decent way of having some cohesion, but it still has its issues when you want to add a step in the middle of that process. But it's like this bread maker. You hit the button. Bread makers are great. You just throw in the ingredients, you hit the button, it makes your bread. But if you want to add a step in the middle, you really can't do that very easily when everything's fixed to be, look at, just say go and I'll do all of the things. And this is comparable to an assembly line. Your code goes from station to station, and just like an assembly line, you can't go in the middle of this, pull it apart, and add another step. Maybe I want my Model T to be a color other than black. Well, the assembly line just wasn't set up for that. We're not going to do that. So this is good, but it does have its drawbacks once you want to change things in the assembly line in this procedural module. It's tough to modify, tough to test as well. You're pretty much your only testing is end-to-end testing. I'm going to have a user put this in the API endpoint. I'm going to call this endpoint with these passwords. And then I have to make sure, I have to check, okay, did the database get the right values? Was that email fired off? I have to check all this stuff and just hope that it all happened. I don't have any fine-grained testing ability with procedural cohesion. Communicational cohesion, again, a decent one that has some drawbacks. It's where we're grouping functionality together based on the data that it uses. So if there's a certain data set, maybe I have, in 116, we're doing rhyming dictionary is one of the assignments right now. And there's this dictionary that maps words to their pronunciations. So if that data set, anything related to that data set, we just throw it all in one module. That would be communicational cohesion. Instead of allowing multiple modules to access that data set and having, say, one module that parses it and then other modules that get to use and consume that data, this is putting everything around that data set one big module and using that as our cohesion model. So there might be bits of functionality that are extremely different, but if they're related to the same data set, they use the same source data, putting them together. Not a terrible way of doing things, but there are better options. Let's talk about the two best ones coming up. And again, this makes testing and debugging very hard. When you have, say, one part of that module modifies that data set in some way or modifies the parsing of it, you can have some really tricky side effect bugs come up. Whereas if you have separate modules with separate copies of that data, or at least references to an immutable version of that data, you can get around some of those things. So this is fine, but you end up with too many bits of functionality that are so unrelated, and the only thing they have in common is they use the same source data set. It's not really not always the best way, not the worst way. We're getting better here, but not always the best way to organize your functionality and split up your modules. So let's get into some of the top ones. Functional cohesion. This is sometimes, and I should have mentioned this off the top. A lot of the things in this lecture are controversial. That's why I'm hedging my bets and not saying this is the best one, this is the best one, this is the crappy one. They all have their pros and cons, but there is a general progression of worst to best here. This one is commonly referred to as the best one, functional cohesion. So functional cohesion is building modules around a single task. We have the single thing that each module is responsible for, and we use the single responsibility clause. Is that a clause or a rule? But single responsibility for each module. So if I'm writing a function, I write that function to do one thing and one thing only, and that's it. If each function is just doing one thing, or each module is just responsible for one specific thing, maybe I have a module that's just responsible for hashing passwords. That's all it does, and then in other modules, I can use that module, call its methods, access its data, I guess that example wouldn't have data, but use that in other modules. But that module is responsible for one thing and one thing only, and it does it well, and it's tested. I just have to test, okay, if I give you this string, do I get the hash of that string using whatever hash function is built into this thing? And I can check that, test it, debug it. If those tests fail, okay, I gave you this string and I didn't get the hash I expected. Are you actually calling the hash function? Oh, no, you're not? Okay, that's easy to fix. Very easy to work around code like this. If I want to change the hash function throughout all of my code base, I just go to my hashing module and update that hash function. I want to go from SHA-256 to SHA-3. I just go to that module, update it, done. I mean, probably not done, not if it's a live app, because if I have SHA-256 hashed passwords in the database already, that example is going to be a lot more difficult. But in terms of the code, if we're redeploying a fresh copy of the code, no data, no stored passwords, it's easier to make that update. SHA-3, it's I don't know how adapted it is, how much it's been adapted so far, but it's the next SHA. It's the winner of the competition of what's going to be the next SHA algorithm. A bunch of teams competed. They came up with their own hash functions, and SHA-3, the winner of that got the name SHA-3, and they're the new SHA. But I believe it's SHA-2 is still used quite often. And SHA-512, I believe, is still SHA-2, but with 512 bits. I'm a little fuzzy on that. I could be a little bit wrong there. But I'm pretty sure that still uses SHA-2. But I could be wrong. But so functional cohesion, this is a nice one. Everything's broken down into one piece of functionality. Like one task. You got to assign one task, which is one part of a story. And that task, you build a module, you build some code that does that one thing. And then you test it. You merge it into your, well, I guess you would just push it to your sprint branch. Push it to your sprint branch, and that one's good to go. You get another task, you build that one function, one piece of functionality, and then as you get to the story, actually completing the story itself, you just start calling your modules. Hey module, do your thing. Hey module, do your thing. Hey module, do your thing. And just write a little bit of glue code to pull these modules together in the way you want. And then you get this nice, fully tested program that's easy to update. You want to change some functionality, you go to the module responsible for that functionality and you change it. Super easy. This is a fantastic way of designing your programs. You're effectively encapsulating all the functionality into its smallest reasonable chunk to be able to keep the code base simple, testable, expandable, and usable. Another really good one, informational cohesion. This is basically the basis of OOP. It's similar to functional, except you're not just having each module focused on one single task, typically with input-output behavior, the functional behavior, with functional programming. But this is OOP, where we're wrapping functionality around a certain chunk of information. Not an entire data set like we did for communicational cohesion, but around a certain chunk of data. And this is what objects are. Objects are a wrapper, kind of a data structure, I guess. Not a data structure, a chunk. I don't know. A class. I'll just call it an object. I'm used to calling them objects. I'm sure you are too. An object encapsulates data and functionality, or data state and behavior, as we say in 116. But you have some data in its fields. You have that data stored in there, and then functionality, which can depend on the current state of the object. Now, there's a big debate over FP and OOP, what's better and what's worse, etc. So informational and functional is going to bring up that whole debate. Informational can be a little tricky to test and debug when you have side effects, when you can call some methods and it changes the state of the object. Those can be tough to debug and tough to write tests for. With functional, you're just testing input-output behavior, so the testing is a bit easier. That's my take on it. But there's all kinds of... Just Google FP versus OOP. You'll get all kinds of crazy debate. Oh, we're 2 minutes over already. Here's a class. Informational cohesion. Cohesion can pay off. It can take some time in designing your software, but pay off. Once you have your code organized into meaningful modules that make sense and are easy to test, expand, and use, it's going to make things a lot easier. If you have way too much code in a single module or a single method, things are a lot tougher to work with. I'm sure you felt that before. And code reusability, this is an important part of it, is some study found that only 15% of code is actually new. It's just code that's recreating features of code that you've already written or somebody on the team has already written, and you're just recreating it because you don't have good usability. And good teams can get up to about 40%, according to the study. 40% code reuse, having good cohesion, good modularity, and good just good design practices, and get up to 40% code reuse, which is very great. Have cohesion, and make sure you're getting your sprint ready. Sprint 1 demos this week, or next week, sorry. So make sure you're getting ready for that, and do what you got to do with that. And here's the one I want to highlight. Make sure you're studying that grading rubric. When you go to your demo, it's your responsibility to make sure you're demoing everything in that grading rubric if you want to get full credit for the sprint. It's up to you. You got to pull up your project. Somebody, at least one person on your team, will pull up the project, share your screen, run through a demo of it, show off what you've accomplished as a team since the previous sprint or from scratch for this sprint, and then go through your Scrum board. Make sure you show off all of the things that the grading manager needs to see. One of the things on the grading rubric is that your commit messages on your commits are good, are decent at least. So you're gonna have to go into your repo, show off some commit messages. If I were the PM given the demo and looking through the rubric and making sure you had what you say you have, I would pick random commits and say, can you go to your commits and show me the 5th commit on the list, the 5th most recent commit, and then do some spot checks. Okay, now show me this random commit that I chose. So to get confidence that all of your commits do have good messages just by picking random ones. If one member on your team has crappy commits and that's one of the ones the PM chose, commit messages, that's the one the PM chose, well, hey, as a team, you didn't do what you were supposed to do. Sorry, your grade's bad now for that particular row in the rubric. So just some words of caution there.